Hello everyone, my name is RauSimple. Welcome to the next tutorial. So today we are going to discuss the remaining part of week 3 assignments. So the remaining are predict.m and the cost functions regularization.m. So in the predict.m, what we just want to predict if the values is greater than 0.5, we are going to predict it as a 1, and if the value is less than 0.5, we'll predict that as a 0. So what we are just writing this m is equal to size of x comma 1, which is nothing but number of training example, and p is equal to zeros of m minus 1. So it will basically declare a vector of size m, and all the values will be 0 0. Now what we are doing, we are just writing h of x, that is nothing but this is our hypothesis for logistic regression, right? So we are just passing sigmoid of x into theta, and this will predict the values, what is the value of h of x, and if the value is greater than 0.5, we'll say that value will be 1, and if it is less, it will be obviously 0, because already we have declared everything as a 0. So whatever will be greater than 0.5, that will be updated as a 1, and the remaining will be 0. So this is about the predicting. Now coming to the cost function regularization.m. So before going to this, I just want to explain why basically we need. So suppose what happened, consider a linear regression. So in linear regression, suppose the linear regression has predicted a line which is completely overfitted on the training data. Okay, it is overfitted on the training data, and the cost function of linear regression, we know that is nothing but 1 by 2m summation of I is equal to 1 to m, and this is the hypothesis minus y, that is the predicted value whole square, right? So what will happen in this, when the line predicted is completely overfitted on the data, so this error we are going to get the 0. Now what I'll do, I'll just add some extra value in it. Suppose I have added 2 in it. So when I'll add the 2 in it, now the total value, this cost function became 2, right? This cost, and in linear regression, what is our target? We want to reduce this cost function, right? The cost function should be less or minimum. Now suppose there is another line, this is a line, and for this particular line, again suppose I got the error, this error I got, suppose somewhere around 0.2, and the addition value, the value which I added, it is just 1.6. so what I'll get 1.8. now the cost functions for this second line is less, right? The cost function for the second line is less as compared to first line, and that's what we basically need. We don't want our line should be overfitting, right? Or our training data should be overfitting, or the model should be overfitted, right? Because we don't want our model should be overfitted. So we want obviously this line, because this line is more better than this, it is giving less. So to reduce the overfitting, we are just going to add some additional quantities in the cost function, and what we are going to add, that value is nothing but equal to lambda by 2n summation of I is equal to 1 to m, and here theta j whole square. Okay, here j is equal to 1 to m, you can theta j whole square. Okay, so this is also known as L2 regularizations. If you write here modulus, so it will be L1 regularization. So what we are going to do, we are just going to add some extra values in the cost functions in order to reduce the overfitting. So that is what the known as regularization. Okay, but make sure here one thing, when we are writing, like suppose the equation is y is equal to mx plus c, right? So this is when you replace m is theta 1, so it will be theta 1 x1, and instead of c, what I can write, theta naught x naught, where x naught is 0, right? Sorry, x naught is 1, so here x naught is 1, and this is c. So we are not going to penalize this x naught, right? Or theta naught, we are not going to penalize this, we are just start penalizing from the feature 1. So that's the thing. Now coming to the implementation of the octave implementation. So before going to here, see here what we are going to do in the just cost function, we are just going to add lambda by 2m summation j is equal to 1 to n and theta j whole square. So these extra values we are just going to add in the cost functions. Okay, now coming to the octave implementation of it. So what we do, basically we write the same cost function 1 by 2m sum of minus y log this is the same cost functions which I explained in the previous part 1. So the same cost function plus lambda by 2m, this is the values which we are going to add for the penalizations, right, or to reduce the overfitting. So lambda by 2m into sum of theta, and obviously just now I told you here that we are not going to penalize this theta naught, right? We are obviously going to penalize, starting penalizing from the theta 1, that is from feature 1. So we are just writing from second, right, which will be present in the second column of the this theta. So from second till end, and we'll do whole square for each value, right? So this is what the cost function. Now coming to the for gradient. So for gradient, as I told you, we are not penalizing the 0 1, right, theta 1. So when you are not penalizing the theta 1, what will happen? We don't penalize this also, right? In the cost function also, it will be the same as the linear regression, that is same as the logistic regression, gradient 1, that is 1 by m and x. Here we are just going to take the first column, right? First column of x. So first column of x transpose into h of x minus y. So this is the gradient. And from the second time, because we are penalizing from the second one itself, right, from theta 1. So when you are penalizing this, so if I'll do the differentiation of this second part, so what we'll get, we are going to get as a lambda by 2m, and the differentiation of this whole square is nothing but 2 into theta j, right? 2 to get cancelled basically here, and it will just lambda by m into theta j. So that's what we are going to do, lambda by m into theta j. So theta here, from where it starts, it's obviously we are doing from the theta, we are taking the second to tail end. So we'll just take from second to tail end. So this is nothing but the vectorized implementation of cost function regularization of m. And why we need the regularization? Obviously to reduce the overfitting. And what that do? It's just going to penalize the other features. Indirectly what it is doing, it is just reducing the number of features, and that will reduce the overfitting. So that's all about today. If you have any doubt regarding this particular topic, please comment down below. I'll be happy to answer. If you like this channel, please like, share and subscribe. Thank you.